Hey guys, welcome back. In this third session on selection sorting, we are going to look at how the code for selection sort looks like, and then we are going to do the analysis of this code and find out the time complexity for the algorithm. So I have this base code ready where I have this array. Then I created an object of the selection sort class and called the sort method on selection sort. And after that, I am printing the array. Here, I have this class. In the constructor, the class member array is initialized with the array passed from the app.java. I also have a swap function because we need to do swapping of two values as I described in the algorithm where I described the examples and how the algorithm works. So this swap function takes two parameters which are integer values and swaps the values on these indexes in the array, right? Pretty trivial to understand. Okay, now let's look at the algorithm part. So as I described in the example, we are going to do a for loop on n minus 1 items. So let's say my length of the array is length, and I am going to do the loop on n minus 1 items, which is from 0 to length minus 1 less than length minus 1. Okay, and then I will have a inner for loop which is going to look at the part of the array which is not sorted, and which is for every iteration the part of array which is not sorted is I plus 1. So in the first iteration the whole of the array is not sorted. In the first iteration the first index is sorted. In the second iteration until second index the array is sorted. So this means the inner loop is going to go from I plus 1, right? Because if I is 1, then the array part which is not sorted is from I plus 1. Or if I is 1, then j should be 2, right? And then this is going to go until length, because we are anyway have to find the smallest value in the unsorted part, which is going to go at the very end of the array, and j plus plus. So let's say when I do the innermost loop, I need to do a initial min value, which let's say I will say is at index I, because let's say in our first iteration the value at first index is going to be the minimum which we had found last. So if we say the minimum value currently is at index I think we are not incorrect, right? I hope you are able to follow what I am explaining. If you're not able to follow what I'm explaining, I would say maybe look at the previous sessions and maybe do this video from the beginning, go slowly, understand what I am explaining, and try to figure out. And if you are still not able to understand, write in comments which part you are not able to understand, and I am going to explain it to you. So now what we have to do is we have to find the minimum value, which means as we progress on J, if array J element is less than array what is minimum, which is at I, we are going to update this min value with J, right? And that's all is going to happen in this inner for loop. And when we come out of this inner for loop, if we have found a new minimum value, this means our current minimum is not going to be equal to I, because if we have found a new minimum value, it will be picked from a value of J, and which is going to overwrite the original min value which was from I. So then a new min value, which means min is not going to be equal to I, and if that happens, we are going to swap the min value with the value of right. And this is what a selection sort algorithm looks like. Pretty easy, small. Let's try to run it. Let's run it and see what the output we get. And our array is sorted. So if we look at how much time each line takes, we are going to say this is going to be running for n-1 times, or for simplicity, let's say this is going to run for n times. This will run n-1 times. This will be running for every I. This is going to run J number of times. I'm sorry, length minus 1 number of times. So this is actually running n minus I minus 1 time, right? Because J is starting from I plus 1 and it is going until n, right? Okay. This will run probably n minus I minus 2 times, and this will be some constant, and n minus I minus 2 times. After coming out, this line will run for some constant and n minus 1 times. Okay, and this is again n minus 1 time, right? So this is actually a swap function. There are a couple of instructions here. there are no for loops. So for simplicity, let's say this is running for a constant and then n minus 1 times. So this is the total time complexity of this algorithm. I need to do the summation of these instructions actually. So this is summation of n minus 1 n minus I minus 1 times, because this line is running multiple times, or actually this number of times for every I. Similarly, this will be summation, and this will be summation for some value x is equal to 0 to n minus I minus 2, right? So let's look at in detail and do the analysis of how much total time this algorithm is going to take. Looking at the code we just did and how much time each line takes, we can say it is C1n plus C2n minus 1 plus one, right? Plus is equal to some constant C3 C4 n minus I minus 2 dx plus C5 plus, okay, this should be actually C4, this should be C5, C6, and then C7. Then C6 n minus 1 plus C7 n minus 1. Okay. So we can see if we ignore the lower order terms, which are these, and if we keep these, which will be sum of the terms from 0 to some value n, which will be, and if we say our n is some value this, so this will come out to be C3, which is roughly n square. So if we keep the higher order terms, which are these, this will be n square plus n square plus n square, and discarding the lower order terms, which is 3n square, or we can say, right, on an average this will still be n square, because the inner for loop is still going to run, right? Okay. In the best case scenario, if our array is sorted, the inner loop is going to run only one time, because if we take an example, our array is sorted until here, and this is the unsorted part. We are going to find the minimum value here, and we are going to swap it from itself. So the inner loop is going to run only once. So all these terms will be constant, and we are going to get the lower order values. So then our best case would be n, because the higher order terms, which are n square, are gone, and we are left with the lower order terms, which are here. So average is and worst I'm just correcting it, and that's our analysis for the selection sort. I hope you liked this video and was able to understand how the algorithm works and the analysis part. If you have questions related to any of the uh, videos for selection sort, please mention in the comments and I will try to explain more. I'm going to end this session here, and probably we'll see you in our next session on other sorting algorithms. Thanks for watching, and bye for now.